Alright guys, so we've already seen how the sine and the cosine function looks. Now we're going to be looking at the third type of function in this chapter, and that's the one that's going to be about the tangent function. Now this is what the graph looks like for a tangent function. And you're probably looking at this and you're like, well, why is it that you have asymptotes in this? And the reason is because you have to go back to the equation, or one of the identities that we've seen in the previous chapters, and it says that tangent of x is equal to sine of x over cosine of x. You can see that this is a fraction, and whenever the denominator is equal to 0 in this would mean that the overall function would be undefined, because you know that whenever you have a fraction, and if there is a 0 in the denominator, it makes that fraction undefined. So what do you notice about this equation? It says that tangent of x is equal to sine of x over cosine of x. So what that means is that whenever cosine of x is equal to 0, it's going to mean that the tangent function is going to be undefined at that point. And you can see that from the unit circle that the cosine of x is 0 at pi over 2 and 3 pi over 2, or pi over 2 and negative pi over 2. You know, let's actually draw this out, see if you guys remember this. Alright guys, so on the unit circle, you know that if you're looking at this point, that's the 0 degrees or 0 radians, which is also the same as 360 degrees once you complete that revolution once around the circle. The coordinates that go with this point are 1, 0. Once you go at the top, this is 90 degrees, or 0 pi. The coordinates that go with this one are 0, 1. Once you get to the 180, the coordinates are negative 1, 0, 180, or which is the same as pi in radians. And then of course, once you're at 270 degrees, or 3 pi over 2, the coordinates to go with this one are 0, negative 1. Now, you also remember that if you're looking at the coordinates, the x-coordinate represents the cosine function, and then the y-coordinate represents the sine. So if you look at 90 degrees, and if you look at 270 degrees, what you're going to notice is that the cosine is 0 at these points. So what does that tell you about the equation that you just saw on the left side of the notes? It said that tangent of x is equal to sine x over cosine of x. So if this is 0 at 90 degrees and 270 degrees, it means that the overall function, which is tangent of x at those points, has to be undefined. And that's why if you go over on this side, by the way, 270 is the same as saying negative pi over 2. Okay, keep that in mind, because remember, whenever you measure the angles clockwise, you're going to be measuring negative. So if you were to go this way, you know, from this point all the way up to that point, this would be negative pi over 2. But you know, since we're always measuring stuff from the positive x-axis, we call this 3 pi over 2. But negative pi over 2 and 3 pi over 2, it's the same angle. Alright guys, so let's go over on this side. Now that you've seen that pi over 2 and negative pi over 2 are going to make the tangent function undefined, what that means is that the tangent function does not exist at those points. So we're going to have asymptotes running up and down at those points, and you can see that from the dotted lines that they have there. This represents the asymptotes. Okay, so you got the asymptotes on this one, and then you got the asymptotes over on this side as well. And you can see that the tangent function is constrained within those asymptotes. What else do you notice about this function, guys? You can see that the shape repeats itself from negative pi over 2 to pi over 2, but then you also know that the distance from negative pi over 2 up to 0 is 90 degrees, and then from 0 up to pi over 2, that's another 90. So what does that tell you? What can you say about this overall distance that's right there? That's 180 degrees over pi, and you can see that the tangent function has that same shape every 180 degrees, or every pi. Remember what we said about the discussion in the class, that whenever you repeat the shape, that's known as one period. Okay, so what does that tell you about the period of this? Unlike the sine and the cosine function that actually repeat every 2 pi, this function repeats every 1 pi. So the period of a general tangent function is not going to be 2 pi, it's actually going to be 1 pi, as they have it in the notes. Alright guys, so based on this, what we're going to see is that, you know, from negative pi over 2 to pi over 2, this is what the function is. It starts at the bottom and then goes all the way up, and it continues in the negative y direction, and then it also continues in the positive y direction, which you can see is indicated by the arrow points on this. You can also see that from pi over 2 to the next 180 degrees, which would be 3 pi over 2, and you can also see that from the unit circle, because look, this is pi over 2, or 90 degrees. 3 pi over 2 is at 270 degrees, and the distance from pi over 2 up to 270 degrees, or pi over 2 up to 3 pi over 2, is 180. That distance right there is 180, and you can see that the tangent function starts repeating every 180 degrees, or every pi radians. Alright guys, in the next video we're going to go over a couple examples so that you guys know how to use the transformations, just like with the sine and the cosine function, so that you guys can apply the horizontal and the vertical translations, and then any of the stretches that you're going to see in this function. One thing that you have to notice is that this function does not have an amplitude, meaning that the amplitude is undefined, because in the sine and the cosine functions you had a starting point, or you had an ending point, a max or a min, but in this function you can see that this graph continues. It doesn't matter which one you're looking at, you can see that the graph continues either in the negative y or in the positive y direction forever. There is no ending point, there is no finite point that you can say would be the amplitude in this. But this is what the graph looks like for a tangent function. Alright guys, this is it for this video. We're going to continue with a couple more examples and stuff in the next one.